definitions like domain and range, that goes back to all possible x values, all possible y values. And you can see that on the picture in the bottom right corner there that I drew a parabola, which goes with example 1, basically looking at y equals x squared parabola. And the red lines are indicating that I am pushing all those values, all those points down onto the x-axis. And I asked the question in the class, how much of the x-axis would get covered? And lots of people said all real numbers. And so that would be your domain. Those would be all possible reals. And you can write it with the negative infinity to infinity, or you can write the all real number sign. I talked about how if I ever get a tattoo on my bicep, that's what it's going to be, the all real number sign. The range would be if you push the entire graph towards the y-axis. That's what all those green lines are. And if you push all those points to the y-axis, then you would get from 0 on up. That's the range. It would include 0 because it does touch 0. It goes straight up from there. So that's the possible y's. Now, how do you determine if something is a function? Well, the definition, you can see it in the blue box there. A function from a set D to a set R is a rule that assigns to every element in D a unique element in R. Fancy definition to say each x has exactly one y. And by saying that each x has exactly one y, we get our definition of what we call the vertical line test, which I know when you were growing up in Algebra 1 and in middle school, they called it the pencil test, okay? Which drives a knife through my heart, so please don't be someone who does that to me. You can abbreviate vertical line test with VLT. It will allow you to do that. If you pass a vertical line through the first graph, it passes. Every time it passes the vertical line test, we say, yes, it is a function. So the second one also passes, but the last one does not. It's a failure. It fails the vertical line test. That is a big no. Now, what do we mean by failing? Passing would mean each vertical line has only one point on the graph. So as you pass a vertical line through the graph, you're looking to see that it touches only one point at a time. And you can see from the one that I drew here, and if you want me to draw another one, I can. The old one set there. You end up with, it fails the vertical line test. Okay? We also talked about, does every function use all real numbers for its domain? The answer is definitely no. And I know that there are some of you students out there that think that if you don't know what the domain of a function is, you subscribe to the rule, when in doubt, all reals. That is a very bad way to handle these situations, and you will not get credit if you decide to go that route. Excuse me. For instance, this is the volume of a sphere formula, and it's true that you can plug any number in the universe in for R. There's no restrictions on raising something to the third power. Then you can take that number times pi. Then you can take that number times 4/3. But, so that would be called, in fact, in this purple box you see here, we call the implied domain. So the implied domain for this would be all reals. But that's not what we call the relevant domain, because the radius of a sphere cannot be negative. And some might even argue that it can't be 0. So, relevant domain is different than implied domain. Implied domain would be what the mathematical formula will allow. Relevant domain would be what the story problem situation will allow you to plug in. Now, there's a couple extremely important points that we need to understand here. I'll use a line to kind of separate these. When you're dealing with square roots, the part under the radical has to be greater than or equal to 0. It can't be negative. Many of you already know that. In order to graph it, it can't be negative. Just like denominators can't be 0. green down there, a fraction 1 over x. The denominator can't be 0. Those two facts are extremely important to me. So for instance, in letter F of example 3, we have x plus 3 underneath the radical. That x plus 3 has to be greater than or equal to 0, which causes x to be greater than or equal to negative 3, which means that's the domain from negative 3 bracket to infinity. Well, what's going on in the next example? Well, there's two things going on in the next example. You've got radical x over x minus 5. So we've got a square root in the top, and we know that square roots have to be greater than the part under the radical, which would be this part. Oops, sorry. Gotta lock it in place. The part under the radical has to be greater than or equal to 0. We also know that the denominator, which is x minus 5, cannot be equal to 0, which means that x cannot equal 5. In tomorrow's video, we will take these two ideas, both the greater than or equal to 0 and the not equal to 5, and we're going to combine them and make a domain for this function.